Okay, let's start this webinar. Thank you, everybody, for joining today. I'm Daniela Blesent. I'm professor at Universidad de Medellín in Colombia. I'm the leader of the IGCP 636 project, which is a research network funded by UNESCO under the IGCP program, which is the International Geoscience Program. Within our network, we want to promote the use of geothermal resources as a clean, low-carbon base load and renewable energy. In 2022, we started with this activity, this online activity, like webinar series that they were called Geothermal. We started with webinars that were focused on specific countries, to provide an overview of geothermal development there. This year, we are organizing webinars hosted by each institution that just recently joined our group. So that's why today we are here with two guest speakers, Dr. Alper Baba from the Izmir Institute of Technology, and Ezegul Turan, an expert in next generation geothermal research and development. They recently joined our group, and that's why they are here today to talk about geothermal development in their country. And the recordings of this webinar and all past webinars are available on our YouTube channel that it's called IGCP 636 Geothermal Resources in Energy Transition. You can easily look for it in YouTube. So there you can also listen to past webinars since 2022. We will listen to the two talks. At the end, we leave a space for Q&A. You are invited to write your question in the Zoom chat so we can read the questions at the end of the talks. So we can start. So Ezegul, the floor is all yours. Please go ahead. We are happy to hear you. Thank you for joining today.
Thank you very much, Daniela. I will share my screen.
Now, yes.
Yeah.
Right. Yeah. Go ahead.
Perfect.
Thank you very much.
You are welcome. So, hello everyone. My name is Ayşegül Turan. Before I begin, I would like to thank to Jackson Grimes and Daniela Blesent for the invitation for today's talk. I have a technical background in sustainability and earth sciences. My master degree in sustainable environment and energy systems and my bachelor degree in geological engineering were both from Middle East Technical University, which is located in Ankara, Turkiye. My master thesis was the first academic study on hot dry rock systems, and it focused on the feasibility study for an enhanced geothermal system application in Dikili, Izmir region. This was followed by the doctoral studies at the Technical University of Darmstadt in Germany. My research focus is the reservoir characterization of very thin crystalline basement. It involves different techniques like outcrop analog studies in the field, petrophysical measurements in the laboratory, geostatistical data analysis, and resource assessment. I collaborated with United Kingdom's first commercial geothermal project, which is United Downs, while I was working as an international researcher in the MEET project. MEET was a European Union funded project where we aim to find sustainable solutions for challenging reservoir conditions hosted in very thin basement, which actually corresponds to 70% of Europe's geological setting. Then recently, I have joined Hot Rock Geothermal Research Consortium in US. It is an industry-funded research consortium of the Bureau of Economic Geology at the University of Texas in Austin, and it aims to find and field the science, policy, economics, and technology gaps needed to further develop geothermal energy, which is actually experiencing its golden age. If you are interested to hear more about our research, they were actually presented before in this platform of UNESCO, so you can check the YouTube channel to see the recorded presentation or just check our website. Now I have 14 years of experience purely focusing on geothermal energy. It is not limited to academy, but also includes the industry experience. As I had worked in 3 different investor companies in Turkey, contributing to the country joining the 1 gigawatt geothermal club. I write for energy portals both in English and in Turkish. Since 2017, I had published more than 20 articles, and I have been actively volunteering in different platforms to promote environmental sustainability, geothermal energy, green campus initiatives, now more than 15 years. I need to emphasize that today, beyond my professional affiliation, I speak as a geological engineer who was born and raised in Turkiye. Today's talk titled as Importance of Geothermal Energy and its Innovative Applications, a case study of Turkiye. It is actually the first part. I will bring a social aspect here, and then the Professor Alper Baba will continue in the second part with the technical facts. I will cover the topics of importance of communication and cross-border collaboration, geothermal heritage of Turkey, milestone achieved so far, and the recent status with the most updated data. Here, I will start with the importance of communication and cross-border collaboration. I believe that there is one positive thing that COVID-19 pandemic has shown us. It reminded us that we are all in the same boat. There was no solution for humankind without ensuring the majority was immunized. This actually applies equally to the climate crisis. There is no solution for humankind without ensuring the majority. We need to optimize the use of limited earth sources like the geothermal reservoirs to achieve a sustainable future together. Here you see a figure illustrating the maximum aquifer temperature worldwide, and there are gray colored lines in between countries and states. When it comes to earth science, existing boundaries between the countries are ineffective. There are borders between countries, but when it comes to geology, we have plate tectonics, we have different formations, different lithology, different rock types, and these boundaries are not coinciding with the political ones. That is why we need cross-border collaboration to optimize the production from these limited earth sources like geothermal aquifers, and that is why communication is very important. And that is where the importance of finding a common language comes to the stage. Transferring the output of our research and the accumulated know-how at regional scale to the similar geological settings around the world will help to combat the climate crisis in the long run by decarbonization of electricity production and heating. That is why I say the key to global success is the communication and cross-border collaboration, and one important step in that is the open source research. Now I will continue with the geothermal heritage. Last year marked the 100th anniversary of the Turkish Republic. To celebrate this milestone, various journals, newspapers, magazines published special historical issues. Here on the left-hand side, you see a magazine page summarizing the 100th year era through different milestones. and one of them was geothermal energy. However, the utilization of geothermal potential in Turkey extends beyond the foundation of Turkish Republic. On the right-hand side, you see a photo of the ancient city called Hierapolis, which is recognized as a UNESCO World Heritage Site also. These locations were spa towns, and the use of geothermal resources here dates back to the Roman Empire. This brings us to an important question. How was this geothermal potential converted to economic development? So that we see greenhouses in 1970s and power production in 1980s. These two screenshots are from the first TV channel of Turkey and documented the history beyond that. Here, we need to emphasize, to answer that question, here we need to emphasize the impact of founder vision that underscores the vital role of earth sciences. The vision established an institution dedicated to exploring the country's underground riches in 1935, which we call MTA. When the newly established republic was only 12 years old at that time. So this played a significant role in the economic development. And this vision also involved sending the country's youth, in other words, the university students and the high school students, abroad for higher education and training cadres who strongly believed in science. This underscores the impact of the founders' foresight. Now we will have a look at the milestones achieved so far. I have especially selected these examples of different types of components, in other words, different types of stakeholders who are active in the geothermal sector, to show how they follow each other and how they are connected to each other. All these show the country's commitment to innovative and sustainable energy solutions as it looks towards the future. The drilling of first geothermal well in Turkey goes back to 1963. First pilot geothermal power plant began operating in 1974. First Turkish-Italian seminar on geothermal energy goes back to 1982. First geothermal electricity was produced just 2 years later. And then we have the first district heating in Gönen in 1986. And that work was actually internationally recognized. And we see that in 1999, İzmir-Balçova geothermal heating system was selected as the best practice by European Geothermal Energy Council. In 2005, World Geothermal Congress was held for the first time in Turkey. And since it withdrew the attention, the needed edits like the changes in related regulations and laws took place. Then it boosted the geothermal development in the country. And we see in 2017 the initiative for domestic manufacturing in the sector by Ormatürk, as you know, Ormat. And European Geothermal PhD Days were held for the first time in 2020, just before COVID in Turkey. First geothermal solar hybrid power plant was put in operation just last year. Now it is time to give the most updated numbers as we have had a look to the history. Before starting, I would like to thank my co-authors Orhan Mertoğlu, Şakir Şimşek, and Nilgül Başarır. We have written a conference proceeding and we will be presenting that at the Geothermal Rising conference this year. So this data is compiled for that work and I will be sharing the bullet points out of that with you now. In terms of direct utilization, if we consider the two 100,000 thermal springs and wells existing with drilling depths reaching up to 5 kilometers, then we see the total number in terms of direct utilization is 6,300 megawatts of thermal. And we have different branches here in terms of district heating, greenhouse heating, heating for thermal facilities, hotels, spa like the biological use, agricultural drying, cooling, and ground source heat pump applications are the ways that we utilize directly the geothermal resources. And when it comes to electricity production, we see that the total installed capacity is 1,710 megawatts of electricity with the contribution of 6 different cities in the country. The produced CO2 is being utilized in the production of dry ice. And for that production, the annual amount is 400,000 tons. Here I have added a photo. It is the water storage pond of Kızıldere Geothermal Power Plant. I have taken that photo in the technical field trip of European Geothermal PhD days, and I would like to withdraw your attention to the reflection. If the issue is geothermal, there is always more than meets the eye. What we see in a power plant is not only megawatts of electricity, but also Master of Sciences of research. We need to emphasize the importance of industry and academic collaboration. After looking at these numbers, all these numbers, can we say this is the end for the Turkiye for the production? Is this the end of the story? Is the low-hanging fruit all gone? The answer is no. Here you see a map from a scientific study. And this probability map of geothermal potential in Turkey shows that promising area, as you see the orange colored ones, promising areas correlate with the, but not limited to, proven geothermal areas, particularly located in the Western Anatolia. This brings me to the end of my presentation. Thank you very much for your attention. Now I give the stage to the Professor Alper Baba. If you have any question for me, you can leave it in the chat, then I will be answering. Otherwise, we will welcome your questions at the end of his presentation. Thank you very much.
Thank you very much. Dear Johan, dear Daniel, thank you very much for inviting me to this important event. Today, as Ayşegül mentioned, that we are going to focus about the Turkish geothermal system. I just give about a new application in the world also. Okay. Ladies and gentlemen, good morning, good afternoon, and now in Turkey, good evening, everybody. I'm going to focus about especially importance of geothermal energy and innovative application case study from Turkey. As you know that carbon dioxide emission is a big problem for every countries for the world now. If you look at the values, you see that carbon dioxide emission million tons 2022. You see that China, United States, India, Middle East, Russia, Japan, and Iran is the top countries. They produce the carbon dioxide emission. And then you know that also the surface temperature is going to be increased every part of the world. If you look at the modeling, all the model show that the temperature is now exceed 1.1 degrees. Now reached 1.5 degrees. This meaning that the climate change is a big problem. Now we are discussing about climate change. Therefore, many countries focus about renewable energy. If you look at this is global energy statistic, you see that different coloring here. For example, the green one, this is oil. The black one is the coal, and the red one is the natural gas. And then this part consists of the renewable energy. If you look at this graph, you see that most of the countries now, especially the European country, focus about renewable energy. In renewable energy, you can see that in the nuclear, you can see that hydropower, you can see that wind, and then also you can see that the geothermal. The red one is a geothermal. If you look at this graph, you see that like Turkey, Italy, New Zealand, the Iceland, that now they have enough production for the geothermal energy. If you look at the global energy statistic, you see that now 135 countries have a renewable power target. 156 countries have regulatory renewable power policy, and then more than 3,000 gigawatts of global installed renewable energy capacity. Levelized cost of the onshore wind power and solar PV are now cheaper than fossil fuels on average. And then more than 50% of climate mitigation finance allocated to renewable energy, such as hydropower, solar PV, and wind power. Dear colleagues, if you look at the carbon dioxide value, you know that the carbon dioxide is directly come from the fossil fuels, energy-related emission account for the 3/4 of global carbon dioxide emission. Still, 78% our energy comes from the fossil fuels. Just we have 12.6% modern renewable account energy for the final energy consumption. And then still we have 135 countries have some form of net zero target, covering about 88% of the global emission. A rebound in economic activity led to 6% increased carbon dioxide emission just in 2021. If you look at the just data from 2009 and 2019, you see that the total energy demand grow about 19%. You can imagine 2021, we used just 3,366 US billion was invested in renewable energy. For fossil fuel, subsidies reach about 5.9 trillion US dollar in 2020. This is equivalent to 11 million per minute US dollar for just fossil fuels. You can imagine. Therefore, now we have many phases, many countries, many units now focus about the, that the degrees, these fossil fuels. If you look at the generally share of modern renewable energy, you see that in data, you see that still 78.5% fossil fuels. We have just like 12.6% modern renewable energy. This consists of hydropower, consists of renewable heat, consists of other renewable energy. This is include biomass, geothermal, ocean, solar, and wind power. We use the energy. We used to, that this type of the energy and renewable energy now we use for the power, we use for the building, we use the industry and transport. If you look at the data from just, for example, 2009, 2019, you see that, for example, for power is increased about near the 6%. You see that building is increased about for the renewable energy, increased about 4%. You see industry and agriculture about 4%, transport just a 1.2% increase. Dear my colleagues, why the energy capacity? Energy capacity factor is very, very important. In the world now, two energy leaders, one of the nuclear, the other one geothermal. If you look at the capacity factors, you see that in his solar is 24.6, wind is just 30.6, 34.6. As you see that in geothermal, 70%, 71%. In Turkey now we reach 82%. As you see that nuclear is 92.7. Therefore, geothermal and nuclear is very critical for all countries because solar is affected by the sun, wind affected by the wind direction, hydropower is affected by the climate change, and then coal is they have a low quality, affected the carbon dioxide. Natural gas also they include the high concentrated carbon dioxide. You see that, therefore, now we say that geothermal is very important because nuclear is high technology. They need the good technology. They depend just some countries. But if you want to improve the rural regions, if you have focus about the geothermal energy. Among existing renewable energy sources, geothermal is the only source that can provide base load electricity and effectively replace fossil-based energy sources, and it is secure, inaccessible, dischargeable, and flexible. Geothermal energy is contained in the rocks, mostly as a hot fluid and stream within the earth crust, and is available all times through the years, unlike other intermittent renewable energy sources. If you look at these pictures, you see that in here we have different, that we have a different temperature. For example, in here, you see that we have a high potential, enough potential source, temperatures maybe around 10 and 20. Still, it is possible you can use this energy for the geothermal heat pumps. If you are going to for example, Sweden, if you look at the Lund, Stockholm, they heated by the heat pumps. You see that. And then if you have, the fractures, if you have some, fluid, if you have a hydrothermal system, you can inject it, that it is possible you can, use this fluid for the power generation and then the other activities. And then also sometimes we have, that we have heat sources, but we have not fluid. In this stage, we call that hot rock and geothermal system. Now it is possible we can use this one, but in this system we have to inject the cold water, maybe some gases, and we extracted the the fluid, gases, and others for power generation. As you see that we can use the geothermal for different application, from greenhouse, fishing, food processing, cement, hydropower. Its temperature is going to increase. You can use the different industry also. Generally, if you look at the the electric geothermal energy installed capacity in the world, you see that it's going to be increased every year in the world. And then now the geothermal, global geothermal power capacity was reached near the 60,000 megawatt at the end of 2023. If you look at the installed direct use capacity, as you see, that also going to be increased like an exponential. This is very important in the world. If you look at the direct, the geothermal energy top 10 countries for direct use, according to because they have a good real data at the time, that now is the direct use, China is the first, Turkey is the second. But in power generation, also Ayşegül has mentioned that, as you see that United States, Indonesia, Philippines, and Turkey is coming. You see that still we have 1 gigawatt country clubs, and then still we see that many countries now focus about also electric power production from the geothermal system. Dear colleagues, if you look at the geothermal development, you see that in Turkey is increased, especially after the 2012 because of some regulations, support mechanism, and then the renewable energy, support by the government. If you look at the installed geothermal direct heating capacity per country, you see, especially in Europe, now many countries focus about the direct use application in Europe. For example, Iceland, Turkiye, as you see that also Germany, France, Netherlands, Poland, you see that many countries now focus about this one. Number of geothermal heating plants in Europe now, you see that some installed capacity, plant company, also in development. You see that the meaning that in near future, we can see that many application, geothermal application, every part of Europe. If you look at the maps of these maps, you see that this is the European maps, especially this region they have a very complex geology. They are under the high tectonic system of Himalaya origin system, and then they have very good, the potential for geothermal system. If you look at the just temperature at 1,000 and 2,000 meter depth, the map of the European, as you see that in 1,000 maps, especially for example in the western part of Turkey, you see that temperatures is reach, that the 2,000 degrees, 200 degrees. If you look at the 2,000 meters, you see, especially we can see that the many part of the Turkey, they have high temperature of geothermal fluid. For example, in western, we now reach about the 300 degrees. In center, now we have 340 degrees in here, but still we have not data about this region very well, but still is high potential. You know that the Alp Himalaya origin, they have very active. As you see that in here, the brown color is Alpine fault thrust belt system. In here, the green color is the Neogen extension basin. And then in the blue one is the Neogen oceanic thrust. And then this part is controlled by fault. This is the strike slip fault, North Anatolia fault, South Anatolia fault. And then this part is the compression extension system. And then these regions, especially this part of the world, you know that they have a high potential of the geothermal system. If you look at a little bit detail in the Anatolia plate, this is the Turkiye regions. Let's see in here. As you look at in the Turkiye maps, in here, as you see that we have some, you know, that some components. For example, this part is area of the strike slip, now tectonic regime with the thrust component. In the center part, as you see in here, we call that the area of the strike slip now tectonic regime with the normal component. And in here, as you see, that is the area of the extensional neotectonic regimes. But in here, we have control by the major fault. This is North Anatolia fault, South Anatolia fault. And then in here, as you see that many volcanic eruption points located in this region. If you're going to a little bit chill, as you see that in here, we have some different color. For example, this is the yellow color is the Neogen volcanics. You see that this is the, for example, this is the green color is the Cretaceous volcanics. But in here, you see that some granitic, this is the metagranite in here. As this is very important because this is heat source of the system. If you look at the map, okay, this is we have a good tectonic, and then we have a good heat source in here. Therefore, if you look at the map of Turkey, you see that in here we have a dot. This all dot, you know, that is this all red dot is a geothermal. And then you see that we have many, you know, the wells and natural spring around the Turkey. And then again, this is the geothermal resources. But if you look at in here, you see that the meaning that in every part of Turkey, we have a geothermal fluid and geothermal spring. Just in the western part of Turkey, especially this is, we have two grabens. We call that Büyük Menderes Graben, and this is Gediz Graben. In here, we have more than 1,000 wells, reinjection wells, production wells, unused wells, clubs, and a direct well. But in this part, this is the southeast of Turkey. We have many wells in here. This range from 1,270 to 3,096 meters. All the wells have, this is the all wells in this region, they use for the oils. But these wells, also they include the geothermal fluid. The temperature range from 40 degrees, 130, 60 degrees, according to some data. If you look at the temperature maps, you see that in here, the highest temperature in Turkey, now see in the central part of Turkey, now is the temperature is reached 341 degrees. The depth is 3,845 meters. But also we have also high temperature in the western part of Turkey. In here, we reach 300 degrees in Aydın Germencik. And then also again, we have also the Manisa in the Gediz Graben, you know, 287 degrees. And then also Denizli, you know, that in again, this part, we have also the 240 degrees. Okay, if you look at the maps, you know that these maps were created by our groups. As you see that in the western part of Turkey, city at the center, and then some eastern part of Turkey, they have a geothermal fluid. But we have not any data in here. You know that if we have very few data in this region, I hope that in the future, if we got more data, these maps will be created and then they will change. If you look at the geothermal power plant in Turkey, as you see that most of located in western part of Turkey. This is the Büyük Menderes Graben, as you see that Gediz Graben in here. And then we have 4 power generation located in the northwest of the Turkey. This is the Troya region. And then we have also one of the power generation located in the Afyon, in the center Turkey. Still, we use the cascade application system. For example, now this is some companies. You see that in the different region, but they produce a power generation, but also they use for the direct district heating and then greenhouses. This is the good example about the system. If you look at the power generation type, you see that we have a binary system about 52, but also we have a double flush, single flush, triple flushing. This is quite good. We have very nice, very good example in the Gediz Graben. You know that in the same place we have a binary. Also we have a flushing system. But for geothermal direct use application in the world, as you see that generally about 58% 8.8% of they use the ground source heat pumps. And then 80%, 18% is just bathing, swimming, 60% is for space heating, just 3.5% the greenhouse and open ground. And then also we have like 1.3 is the aquaculture pond and reserve wave heating. But when we compare all the world, the world leader in the direct use, you see that with heat pumps, that China, US, Sweden, Germany, after then Turkey. But without heat pumps, China and Turkey now is in the second. Again, as you know that we have in the different temperatures, we can use for the different industry. For example, in Turkey now we have not used so much heat pumps. I believe that in near future this is going to be increased. This is we did this study for the World Bank. You see that, so for the government also, you see that this is the Turkiye Geothermal Strategy Report 2000. According to all the data, that we have, for example, 60 gigawatt theoretical potential, but now we use just 8.5% of this energy. We use for the district heating, greenhouses, the thermal facility, geothermal fluid, cooling, geothermal heat pumps, and food drying. Let's see that in the Turkey maps. You see that every part of the Turkey, you have seen some application of geothermal. For example, in western part of Turkey, you see that in here, this picture from the Alyala is a Pergamon region. But for example, this is in Izmir, this is my city, this is my campus. In our campus, located in geothermal area, and still we have a geothermal spa. And then you see that this is for Pamukkale. Pamukkale is very famous scaling problems regions, but it's very nice manifestation for the tourism. And then you see that all the part of the site, we have very nice sample about the geothermal. If you look at the maps of the Turkey, as you see that this is the different application. If you look at in here, you see that different color. For example, the blue one is the thermal. You see that this one is purple is the food dry. You see that the green is the greenhouses, and then the space heating, that's some. You see that most of the located in this, but now we see that in the center. I hope that in near future we can see in the eastern part of the Turkey also. Okay, let's see that the district application in Turkey. The first one is start in 1964 in the Gönen in Balıkesir in this part. But this peak color show that the place, some place heated by geothermal, especially now around more than 160,000 houses heated by geothermal in Turkey. And then we have also cooling system. One of the building in geothermal, Izmir geothermal heated by and also cooling. This building has used absorption cooling system since 2018. This is our study area, our campus located in here, but our city in Izmir. This is good example because 40,000 houses heated by geothermal. This is very, very high-tech system, a very good example in the world. And then you see that we have many wells in the city center. This is the Balçova region, Narlıdere Balçova. And this is conceptual model. The main reservoir is the Filish. We have two reservoirs in here. One of them is the alluvium, the other one is Filish. As you see that this also controlled by the tectonics. And then this is the conceptual model of a region. And then also the thermal tourism is very important for the country. Especially we can see that any indicator in different part of the region. As you see that in here, the colors, that the blue, dark greens. As you see that show that the thermal application as every part of Turkey, but the government decided to, that to focus more regions. For example, they said that this part is the Central Anatolia thermal region for Cappadocia region, and then also they have a Phrygia thermal region. This is related to Afyon, this part. And then also we have Marmara region, we call that the South Marmara thermal region. And then also we have a Southern Aegean thermal, Turkey, Izmir and Denizli Manisa also important for the thermal tourism. Okay, this is to show that the regions of this thermal activity. Dear my colleagues, the greenhouses is very important. Turkish greenhouses industry ranked in the second in Europe in terms of total production. It is concentrated southern province. You see that in the maps, the green colors is open green. This is the show that the greenhouse application, you know, that especially you see that we can see that many places now. For example, this in here, Adıyaman, this is the good example, and also Batman, because we have abundant oil wells, you know, that we use for the greenhouses in here. And then the other things, you know, that at that time we are in the second big for the geothermal greenhouses application. But just I want to focus in here, you know, that the vegetation and the fruit, it is important, but we have to protect this one, because other case, you know, most of the, you know, fruit go to the discard because of the, you know, the time, climate, everything. But dry industry, therefore, very important. Therefore, the government now, the many companies are focused about dry also, dry food sectors. In the Turkey now, the government supported the greenhouse application. Many project was under, you know, the under applications. For example, this is sample about this one. As you see that in near future, we will see that the 21,500 hectares. This is very important. And then also dry industry application. Turkey is currently in the 4th place in the world in the fresh fruit and vegetable. You can imagine, you know, that just about 30% our fruit vegetation were discarded. This is therefore, if you use the, you know, the dry industry, you can minimize this one. It's very important, you know, that. You see that in here, the pink colors, it show that where place we use the dry application in Turkey. We use the dry application in the different region, different type of the fruit. For example, the peach, date, watermelon, pears, you know, that's a good sample. For example, this is this picture from Agrobay in Dikili region. Dikili is very important in Turkey. In the near futures, this all the parts, you know, that under construction, we will see that the world biggest greenhouses in this area in very near. Let's see that the hydrogeochemical and environment problem of geothermal and the innovation part. You know that if you look at the just, you know, sample about the western part of Turkey, as you see that in here we have okay, some grabens, Büyük Menderes, Gediz, Küçük Menderes grabens, and in here they control tectonic extraction zones. But you see that if you take to the, you know, there's some cross section, each part show that the different geology, but we have, you know, it is controlled by the tectonic, but also you can see some intrusion in the system. If you look at in this part, you see that this is the numbers is each geothermal field. For example, number 1, number 2, each geothermal field. If you look at the chemistry of the water, you know that the pie diagram show that the major element, for example, the green one is the sodium, calcium, the red one is the calcium, and then pink one is the chloride. For example, number 1, sodium chloride. For example, number 2 is, you see that is more chloride. As you see, number 3, for example, this is the sodium sulfide, number 3, for example. If you look at the number 4 for sodium sulfide, this is volcanic region. But if you are coming to the western part of Turkey, you see that you can see that blue color. This is sodium bicarbonate. Okay. For example, this is number 28 in this region. You see that in here we have calcium carbonate. Okay. This is, if you look at all this data, the data show that each geothermal, they have different hydrogeochemical properties. Okay, if you want to focus about the, you know, the scaling, corrosion, you know, the element, the meaning that you have to know that each geothermal is not same. For example, in here, you see that some data from the isotope data from different geothermal system. As you see that the isotope data, oxygen and deuterium show that the different region, you know, that located in different area. And then look at these 3 geothermal fields is not far from here, each other. For example, Tuzla, Kastamonu, just like a 30 kilometers far out. And then Hıdırlar, 35 kilometers. Okay, dear my colleagues, look at in here. For example, the Tuzla is the main reservoir, is the volcanic system. But your Kastamonu is granitic system. And here is a granite, also some of the filish materials. You see that in here, that this is but temperature will be changed. If you look at the, you know, that the chemistry, as you see that, for example, okay, Tuzla and Kastamonu is located in sodium chloride, but Hıdırlar is a sodium sulfide. But interesting, if you look at electric conductive values, you see that some of these regions, for example, not far from each other, but electric conductive very low, but for example, Tuzla is, the very high. Okay, because the system is different. And then, okay, let's see that the isotope composition, as you see that each one is a different system according to Kikamba. And then you see that composition, for example, Hıdırlar is, that they fitted by the rainwaters, meteoric water. Istanbul is a little bit different. Mixed water, intrusion of sea. For example, Tuzla is connate type of the water. And then look at in here. This is one of the aquifers, but see that this part is unconfined, this is the confined. You see that in here, water is calcium sulfide, but in sodium chloride. You see that temperature is 100 degrees, this is 250 degrees, because we have an impermeable cap rocks in here. We have not impermeable cap rocks. Okay, sometimes, that you say that in maybe same reservoir, but behavior is different. We have to be careful about this one. And then also you can see that how can affected by, that the precipitation, recharge area, and then how can the change the carbon dioxide. For example, you can see the carbon dioxide, escape, but in here you see that the closed basin system. And then if you, in general term, all chemical elements, both in gas and liquid phase, can be divided into two groups. In geothermal system, we call the trace and geoindicators, some element. This is some tracer element. This is the, that this very important source of the system. And then geoindicators, also our reactive element that precipitated in chemical reaction was equilibrium constant, are temperature dependent. Because this one we can simulation of the temperature of the system. And then some geothermal systems, they include some carbon dioxide. That this is the, but this carbon dioxide values will be changed later with time. But therefore, many countries now start focus about how can we minimize the carbon dioxide, how can we capture the carbon dioxide with the geothermal systems. Let's one of the sample, that in the Iceland, the Helen site power plant, the first capture carbon dioxide direct from air using geothermal energy, that the system. And then second one, carbon dioxide mixed with the water and pump in the deep underground. But when you are, that when you are injected underground, this react with the underground formations. But we can see some scaling problem in here. This is very good sample. In the sample of this one have been done in Iceland. This is the system of the region. This is the carbon dioxide injected the underground system. But you see that in here some sample they have had some scaling, some maybe minerals, and this is to capture the air, carbon dioxide air and then inject it with the underground with the geothermal energy. But in Turkey we have a very good example about the production of the carbon dioxide. If, for example, this is some companies, they produce carbon dioxide for the liquid carbon dioxide. You see that carbon dioxide is very important gases also. You see that we use the carbon dioxide for the drinking sectors at the time. You see that all coke system, they have gases, but this come from the geothermal. And then it is possible you can use the carbon dioxide for minimize the fires. This is very critical. Still we are discussing about this one. And then the other problems for the scaling in the system, you see that this is the production valve and this is the reinjection valve. As you see that from here, for example, temperature 120 degrees. When they come to the surface, temperature fluid may be 170 degrees. As you see that, maybe you see that the pressure will change, temperature will change. And then if we reinjection, you see that temperature may 50 degrees. In this process, that you see that fluid is behaving a different characteristic. Therefore, we can see that the different scale in the different phase. For example, we can see the different type scale in the different this of the phase. Let's see in here, for example, production wells. You can see that the calcite is dolomite is low, but if you look at the injection wells, you see that carbon dioxide, aragonite, and dolomite, scaling is going to be key. The values are going to be increased for the other element. Therefore, we have big project. We just completed this project this year. This is the project name is the Reflect project. This is supported by the European funding. This is redefining geothermal fluid property at extreme condition. We work in all the part of the Europe in this project polluted water project. And then we have very good example. We did study in the Tuzla region, because why Tuzla? Tuzla is the more complex system in Turkey, because the electric conductivity is very high, and then they have more handicap scaling in here. Let's see that example. For example, this Tuzla region, they have 3 wells in here, production wells. Main reservoir is the you see that the volcanics, different volcanic system in here, and this is the conceptual model, especially the cap rocks of the system is the neogen sandstone and claystone, but the main reservoir is the volcanic in here. If you look at in here, the main problem, scaling is one of the important problem in Tuzla geothermal system that reduced the efficiency of the geothermal power plant and caused economic loss, but many years ago. In the Tuzla geothermal system, we can see the silicate-based scaling, which is the most difficult scaling removal is already observed. And then you see that in the scaling electron microscope, this is the inhibitor pipeline scale. You see that different type scales in the pipeline. And then if you look at the pipeline, you see that we can see in here galena and then silicium oxide. In the XRD values, you can see these elements. And then if you see that in the, that the valves, again, we can see the same composition. You see galena and silica and carbonate. And then if you go to the detail, scale sample, again, in scale sample, we can see some enriched by iron, silicate, calcium, magnesium, lead. These elements are associated with the saponite minerals. This is and then that also associated with the galena systems. And this is sodium chloride type system. You see the Piper and Schoeller is the same water system. If you look at the pH values, that we still monitoring of this region. This is very important because this data is very important for all the world geothermal system. Because if you are, minimize the complex system, it's easy. You can focus about the other system. You see that the pH, and then it is interesting to look at the electric conductivity. 80,000. You see the 80 millisiemens per centimeters. This is you can imagine how can this complex system. And then silica values of this region, that wellheads, separators, separated out wellhead. You see that different phase. And then also we can see some elements, for example, we have some boron values. Still we have boron. We can see that many geothermal fluid in the Turkey. But boron is very famous, a very important element. As you remember that Larderora field, when they built, they for the boron extraction, not for the power generation. After then, they transfer to the power. And then the other, also they have a lithium. Some field they have a lithium. The other elements. And then look at in here. This is they have the shift, the meaning that this is the deep circulation system. And then we did many study about the conceptual model of this region. As you see that this is some conceptual, how can the temperature will be changed in the system. And then we calculated the saturation index or all the wells. As you see that again, the subsample spheroid minerals, silica minerals, that going to increase with the temperature of the system. This is important for the site. Dear my colleagues, therefore, we did very nice study in here. We captured carbon dioxide. We injected carbon dioxide in the pipeline, not underground. You see that in Iceland, injected the underground system, but in here we injected in the pipeline. When we injected the pipeline, we minimize the pH. We minimize the pH, and then we are solved the scaling problem. Now the Tuzla is one of the good sample. They use the carbon dioxide for the scaling. This is quite new, and then we got the big award. That we got the for the European committee about this project, geothermal committee. And this is use of the carbon dioxide scaling system. That this one we use the carbon dioxide for injection with the amount of 88 ppm is done control scale problem in the Tuzla region. And this reason for using carbon dioxide rather than other inhibitor in that is caused less corrosion problem under identical harsh condition in the equipment. The other one, you see that in the Büyükmenderes graben, this is very important graben in Turkey. And then in here, we have also seen the different scaling. you see this in the Germanic, for example, the main problem is the Germanic geothermal field is the stibnite. This is the other problem. You see that this is different colors because this comes from the calc schist. You know that this system. We also evaluated all the data. You see that we have many data in here. We you know that we model all the system. You see that how the temperature will be changing the system, and then we saw that in system. We can see that the albite, muscovite, and quartz in the system. And then also with the scale angle microscope, we checked the elemental composition scale. You see that the antimony, sulfurs we can see in the system. And then you see that again, but this is the again some not the electric conductivity is not high, but still this is sodium chloride, a little deep circulation system. Again, this system, a Germanic region system. And then again, we can see the stibnite in this region. You know, we specified stibnite. We just checked about the which temperature is we can suitable for the reinjection. You know that we evaluate all this data. I'm not going to detail, but if they have any question, I would be glad to answer this one. Dear my colleagues, as you know that the element is very critical. You know that especially some critical elements for the many industry, aluminum, antimony, lithium, copper, nickel, you know, is a critical element. This is very important for these countries. For example, in here, you see that some geothermal field, most of geothermal located on tectonic system, but in geothermal system, they have many elements. For example, this is some, you see that some arsenic, maybe you see that arsenic is toxic, but sometimes this be valuable, you know, that don't forget this one. Let's see that boron. You see that boron concentration very high in the geothermal fluid in Turkey. But the boron, if you are discharged outside, this is very negative affected the, the agricultures. For example, in Turkey, we have a Gedis graben. This is the grapes. Grapes is very important for the life system. But, you know, the grapes is very sensible of boron. But boron is very valuable element. You know, that they used to different industry. Don't forget, Larderora is the build just for the boron first, not for the power, later the power. Let's see some example. We did some study about this one. First, we say that why we are not used to the geothermal fluid for the agriculture. Normally, geothermal fluid includes some minerals. Okay, and this is the that if you are extracted the boron and arsenic, the other mineral will be useful for the agriculture activity. We did one of the study. This study one supported by TÜBİTAK and then also Polish, Turkish academician. And then this is our application in Izmir. Do you see that we have many sensors in here? We are just monitoring and then we grow the tomatoes in. And then we saw that use to geothermal is very good. And then in here, we use the treatment, but in the treatment system, we use the solar, we use the hybrid system. We treated the geothermal. We just extracted, you see the boron and arsenic, and then we can use for the fluid for the agriculture. This is you see that production is very well when we compare the other things. As you know that mineral recovery from geothermal is not today, they used to many years ago. This is 18. You see Lardero begin recover boric acid from the geothermal pools. After then, you see that in 1970s, fertilized Mexicanos abundant potassium chloride plant due to the potash. And then you see that in 1970s, 1990s, especially the Iceland, Reykjanes geothermal chemical scale, sodium chloride. And then now is the many countries focus about lithium, mangan, zinc process. Okay, geothermal fluid contains significant concentration potential value mineral like the boron, strontium, lithium, gold, copper, zinc. You know that this is mineral recovery continues to be an issue of interest of geothermal committee. Still, if you are going to the Reflect project web page, you can see some data from the European. This web page, in the web page, they have this is open source. You can see that some, which field they have which type of the element. This is the important. You know that we use the lithium ions battery are used wide in the portable electronic device. You see there's some electronic items in each items we can use the lithium. And then lithium, that the demand is going to be increased. A typical electric car battery package weight between 227 to 545 kilograms. And then you know that lithium resources are divided into categories. One of the solid and the liquid. Solid is come from especially for the mine of the spodumene, but liquid maybe the salt lakes, maybe you know that the geothermal brine and seawater. Especially you know that the lithium production countries like Australia, Chile, China, Argentina, Brazil. But now you know that many countries that focus about the lithium. This is some sample for the evaporate pond in the Argentina, Bolivia, and Chile. You see that, but this is the long, complex, and inefficient process of purifications. You see that this is the extraction process, this is washing process, and then this stripping process. After then, regeneration process. This is the they you know produce preparation of the lithium carbonate products. And then if you look at the demand of the lithium, is expected to increase drastically in the areas, you know, because they used for the electric vehicles, other batteries. This is the critical. And then if you look at the price is changeable each year, but generally the price is going to be increased. You see that the price of the lithium each years, and then strategy. And then it is possible you can, you know, that they use the different methods for the extracted lithium. This is the increasing sensitivity and increased technical challenge. You see different methods, for example, reverse osmosing, evaporation, oxidation, electrowinning, and then inorganic substrate, some sample. Still, we are working the extract lithium in Turkiye. This is our, we are trying to absorb the lithium. You see the absorption system, you know, other colleagues working about this one. But we are investing of the lithium absorption efficiently using some electrosievents, and then we use the different methods for the hypersaline system. You see that if we have many papers about this one, maybe you can, if you're interested, I will glad to send you. And then this is our reactors, you know, one of the pilot study have been done in the Tuzla region. In here, you see that because this is very, it is, you see that in the legs, leg is a cold. You know, that maybe it's easy you can extract, you know, but in the geothermal is a different. It is not easy you can call, you know, that the cooling. It is not easy you can, you know, that collect all the fluid in one place. It is important to, before the injection, you have put in the system. You know that before the injection, you have the capture system. Yeah, our system is directly related to before the injection. We are trying to capture with these materials. You know that we have, we are, you know that we are monitoring about this system. And then, as you know that we have in the world we have a different application, direct, you know, for the lithium for direct extraction and refining technology. This is some stage, some of the lab, pilot, demo, commercial. Yeah, we have also pilot, but we have nothing here now. As you see in the news, sometimes we see that some companies say that now we are produced, but still under, you know, that this people is working about this one. Okay, this you see that this is the different category. For example, absorption. I see that. I think the absorption is a better. Ion exchange, solvent, membranes. You know, membrane is expensive at the time. Electrochemicals system. And then now we have one of the project. Again, the project name is the raw minerals from the geothermal fluid. This again the European project. This again, this is, you see that these countries they're working about this project. In Turkey, we are working about in this project. Many, you know, you see that most of the company I mentioned that most of them is working in this project. This is very good project. Still is ongoing project. I hope that in near future we get very good results. And then also the other application, you see that in here, this is our study we did many years ago. For example, I collected the copper. We just treated this copper with the geothermal, and we produce, you know, the sulfide. This is used for the Apple sector at the time. And then also, for example, this is cheese. You know that the waste of the cheese, they were salty, but we used to wastewater of the cheese. We used to geothermal, and then we produced the wave materials. And then this wave material were used for the biscuit and then child food. And then also it is possible we can produce a salt in the Tuzla region many years ago. The other important thing for the new features, you see the enhanced geothermal system. Enhanced geothermal system are geothermal reservoirs enabled for economic utilization of low permeability conduct rocks by creating fluid connectivity in initial low permeability rock through the hydraulic, thermal, and chemical simulation. This is a sample about this one. Yeah, it is possible you can use the different drilling methods. For you are injected the fluid. This is gas, maybe water, you know, and then you gain the hot water in the system. For example, you can use for the closed loop system. Maybe you see that this is some sample about this one. Inject the you know, the water and carbon dioxide. Maybe get the hot steam vapor to generate power, and then also in the same value you can also use for production and then injection. This book was just published in this year's. This is mentioned about the energy geothermal system. This is very good because they include every energy geothermal system in the world. Good examples. They have a good chapters, each good examples in the world about the EGS system. As you know that the pilot power in Sousse in French, Copper Basin in Aden, and then as you know that 90 plus 6/10 kilowatt hours of the electricity can be generated from the 1 cubic kilometers of the such granite for the 30 years. When we checked the Turkiye, you see that in the Turkiye maps, especially in this part of we have a granite, you know that we have different age of the granite, for example, some of the Tertiary, Mesozoic, and Paleozoic granite in here. This granite includes the high concentration of the radionuclides, such as the uranium, thorium, potassium. Their heat values above average, and they are produced a significant amount of heat. And then you see that this is heat flux maps of the Turkiye. As you see that we have very good heat flux, and then especially Curie depth is you know that the shallow in the western part of Turkey. And then you see that we use the different equation. Reibach equation is the very famous equation. If you use this equation, you know that according to this equation, as you see that we have a huge potential. Just imagine, for example, we did in the just western part of Turkey. You know that in here we just get you can imagine the value is very high, and then according to all the scientists say that that if you take just 2% of the energy, still is very valuable, very valuable. I believe that in near futures, that many countries, also our countries, working about this area. And then just Western Anatolia, EGS electricity generating potentially approximately about 7 million megawatt electricity. Dear my colleague, we published a paper about this one, geothermal resource for sustainable development, maybe if you are interested. And then environmental earth science, also interested. This is quite new papers, just 2022. And then also we published in the Turkish Geothermal Earth Science. If you're interested, you can read about this technology and then system and the calculation. And then generally, geothermal energy production is refined and extended. The benefit continues to grow. With the continuous technological development, geothermal can be expanded all over the world, and the already negligible environmental geothermal impact can be reduced to nearly zero. And then EGS enhanced geothermal system, target of the world. This production potential expected to be realized during the next 20-year period. It is important to understand the hydrogeochemical behavior of the heavy metal in geothermal fluid also. Also, it is important to understand behavior of geothermal fluid in different pressure, temperature, and different reservoirs. Also, it is important to focus on the geothermal mining and minimize the toxic element in the geothermal fluid. Geothermal energy is very important for sustainability. We should minimize the environment problem. Innovative applications support economy and environment. Extraction mineral from geothermal energy is critical. It is important to support the research and development in geothermal application. Thank you very much for your attention. Thank you very much for listening. If you have any question, I will be glad to answer. Thank you very much.
Thank you so much, Professor Halter. Thank you, Aysagur. It was really interesting. It's amazing to see how many geothermal resources you have in Turkey and all the uses that you are giving to them. So I have several questions. I think we are a bit running out of time, but so I would like to ask if anybody has more question. I will. You can activate your microphone. We already received, I think, a couple of questions. Isaac will already answer by chat. People were pretty happy with the talks. I think really informative. While maybe we'll see, waiting a couple of minutes if somebody would like to ask something more. I have several questions, but I will have just one, a general one. So what do you think are the most important aspects or the most important elements that make possible for your country to be now a geothermal leader? I'm talking especially for power generation because 1 decade ago, Turkey didn't have a lot of geothermal power plants, and now is one of the first countries in the world. So what are the main aspects that help this geothermal, this quick development for this industry? Because I was thinking when Isaac showed the first geothermal well that was drilled in the country in 1963, is something similar to Colombia here. We had the first well drilled in 1997, but we have no geothermal power right now operating. So what is the secret of your country? Why was this possible? What is your opinion?
Dear Daniel, thank you very much. As you know that in our country, energy is a big problem. Just in 2023, we pay $25.7 billion for fossil fuels, for oil, for gas, and then some coal. And most of them come from the Iran and Russia, other countries. If you want to be independent, you know that you have to use your energy. But geothermal is the good because it's your sources. Important thing, you have to use very well. Nor in 2007, as you remember that, Ukraine, Russia, Europe, energy crisis. At that time, the government decided to support the renewable energy. You know that we call that the geothermal tariffs. And after that, many companies still enter the system. The problem, if you have a fluid, if you have geothermal, you have to use very well. You have to combine all the local system. You know that the main problem, for example, we built many power generation in the same graben, but some people, you know, not happy because you have to touch the people. You have to use the cascade. Normally it exponentially increase. After then, now it's going to be a little bit increase because of this one. And then support me. If you see that, you know, if you'll be happy, everybody support. For example, now in the greenhouse, supported by government, you know, everybody's happy. For example, but you know, power generation, now people think, you know, that this is the mark. But generally, okay, support mechanism, the government, we need the energy.
Okay, I see. Yes, so that different context because, for example, here in Colombia, we have a lot of hydroelectric power generation, and so yes, this was not. It's really available, the water resources, so there is no need. There was no need in the past for new kind of energy. Now, yes, we are thinking about it too, but yes, I understand. So the context with the
Daniel, just one. In Turkey, we have 38% of our energy related to hydropower, but
okay.
in 2003, we come across the climate change problems. Yeah. You know that the production is just about to come to near the 10%. You can imagine that. Therefore, it's very critical.
Yeah, we are facing the same problem here in Colombia. We're just finishing a really drought period, so there were problems with the generation from hydro. So yeah, that's why geothermal is a good option. I didn't know that you also have a geothermal solar hybrid power plant. I knew only a power plant in US, so this is also really interesting that you combine different kind of energy. Also the injection of CO2 in the pipeline. So you are injecting CO2 into the pipeline of the power plant to reduce scaling, right?
Yes.
Oh, it's really interesting too. Okay, I
Yeah.
never
No,
heard.
you know, carbon dioxide is acid,
Yeah.
low acid. If you inject it the right place, you know that you can minimize the scale. We minimize the silica scaling now.
Interesting. Okay, it's just a pilot project, or it's a
No, this
common...
is now this is good application now. We
Okay.
applied for the international patent also.
Okay. Okay. Interesting. Okay, I think if there are no more questions from the public, just a big thank you to both of you for your time, the information you provided. Will be soon upload the recording in the next days to the YouTube channel. So let's keep in touch. And if the public has more questions, feel free to contact our guest speakers. They can provide you with more information. So thank you very much.
Thank you very much as well.
Thank you very much.
Okay. Bye. Thanks.
Bye bye.
Bye.